Okay, ogives, which is how that's pronounced, and percentiles. So you remember that we can divide a group of data into 4 by finding the quartiles, which are the 3 values, the 1/4, the halfway, the 3/4 way through the list. Q1, Q2, which is also the median, and Q3, and the interquartile range, which is the difference between the upper and the lower quartile, or Q3 minus Q1. Now, if we have a small set of data, we can use the 1var stats command on the TI 83 or 84 to determine the lower extreme quartile, etc., right? So, you know, it saves you having to by hand necessarily put these in order. So I'm going to go second mem 4, clear all lists, go to stat, edit, enter these values into L1, 4.2, 7.9, 1, 9.4, 4.2, 7, 8, 6.2.
It's because
Jacob is like too lazy.
it's not cold.
No.
Jacob, you haven't recorded. Close the window.
6.9.
My God.
7, 5,
Just gonna open them again.
8.6.
Can we please shove Jacob
Okay,
outside?
so we got 15 data values.
Can we please just put it outside for the day?
We've entered.
It's not cold. Who cares?
Say
Do
what?
some noise then.
Hey.
Okay, so we got 15 data values. We go to stat, calc, we use 1var stats. Seeing as everything's in list 1, if you don't have the new firmware, it doesn't matter, you could just hit enter, the calculator runs 1var stats on list 1. We get the mean, we get the sum of the x values, the sum of the squares, we get the standard deviation, we get the number of items, which is 15, which is usually important in that we want to check that back against the data, and we get the min, Q1, Q2, or the median, so we can enter these numbers. So we've got the minimum is, or the lower extreme, right? So we call it the lower extreme. The lower extreme is 3.1. Q1, first quartile, is 5.7. Seriously? Median is 7.5. Should we pause this and see how sensitive the mic is?
Yes, please.
Play it back.
8.3 and 9. All right, it's what? It's about 3 minutes. Just remember this later. We'll go back to this.
Okay. Yes.
Median is 7.5. We got 8.3. And the upper extreme is 9.4. Okay, these are the 5 values we need in order to construct a box plot, right? So we plot these 5 values, 3.1, 5.7, 7.5, 8.3, 9.4. We draw a box, put a line through the median, and draw whiskers out to the extremes. Okay, so we have a nice box and whisker plot. We can use the TI 83, 84, whatever, to construct a box plot. Okay, so I want to do a box plot. I'm going to go second y equals stat plot. Go enter. I'm going to turn it on. Going to arrow down until I'm on the box plot. So actually, I guess that's more than that.
No, it's the first one.
First one. What's that? Second one. My X list is L1. My frequencies are 1. I'm going to set my window. If we want to match what's here, let's go 2.5 to 10.5. And a scale of 0.5s. Y values don't matter. And there's the graph. Okay, so that's box plot. Does that match up? We use the trace button. And we can see the minimum is 3.1, Q1 is 5.7, median is 7.5, third quartile is 8.3, and the max is 9.4. Okay, so that's using the calculator to draw it out and the trace button to then go through it, right, to see that. Determine the interquartile range. So the interquartile range, remember, is the IQR is Q3 minus Q1, which is 8.3 minus 5.7, which is 2.6. So how would we figure out if we had any outliers? What would we do to say, were there any outliers here?
Lower quartile or like upper quartile plus 2.6.
You're,
No, it's times 1.5.
yeah, you're 2/3 of the way there. Yeah, times 1.5. So we would take 1.5 times 2.6 and take the lower quartile, subtract 1.5 times 2.6 and see if that value was out of that range, right? And take the upper quartile and add 1.5 times 2, which obviously this is nowhere near 2.6 this way. And 1.5 times 2.6 is like 3.9, and we can see that, yeah. So everything's well within range here as far as we're concerned. Now, what do we do if we have a large data set? When dealing with a large set of data that's been organized in a frequency table, we use what's called a cumulative frequency curve, or ogive. Definition of ogive, it's a cumulative frequency curve to estimate the quartiles. So, number of customers for movie theater was recorded every day for 200 days. The table below shows the results. Find the cumulative frequencies and use these and the upper boundary of each interval. Okay, so upper boundary of each interval, cumulative frequencies. To draw an ogive, which is a cumulative frequency curve. Okay, so what's the first cumulative frequency? 2. And then? Okay, so we got 2 plus 8 is 10. What's next? 28. Plus 22? Let's go with 50. Plus 64? 114. 120, and that is 160. 180. 198. And if we did this right, should add up to 200, right? Because we recorded for 200 days. Okay, do you understand what the table is telling you? Okay, so on 22 days, there were from 31 to 40 customers. Okay. So now we're going to take this data, we're going to put it into the chart on the following page. We're going to use two numbers, right? The cumulative frequency and the upper boundary of each interval. Okay, so we need to label this. So this is customers at a movie theater. That's the title. The cumulative frequency goes on the y-axis. It needs to go how high? 200, right? So we've got this split up. It's already scaled for us. So 60, 80, 100. But you would figure out a reasonable scale to basically maximize, right? You want it to fill as much of the grid as you can. Okay, so if we couldn't go by 20s, maybe we go by 25s. Okay, now you're not going to do it so, okay, we're going by 27.2s or something like that, right? Like you want reasonable numbers, probably to the nearest 10 in something like this, but you know, you got to base that. And then here we have the number of customers. And the number of customers has a maximum of how many? Okay, so up to 90, 81 to 90. Okay, so 30, 40, 50. In this case, it's actually good to go one beyond that, right? Just to, because 90 is going to be your value, right? Because we're using the upper end of the boundary. Okay, so we're drawing a cumulative frequency curve. It's going to start at, what's our first point? So we have 10 and has a frequency of 2. So we have 10 customers with a frequency of 2. We have 20 customers and our cumulative frequency is now 10. So we're going halfway. 30, the upper end of that boundary, has 28. Okay, so not quite halfway. 40 has a cumulative frequency of 50. 50, 114. 114. Right, you just estimate it as best you can. 60, 160. Oh, we actually get a point. 70 goes with 180. 80 goes with 198. 198. And 90 is 200. Okay, so we plot the points. We draw a curve of best fit by hand, by eye, by hand and eye. Okay? You should end up with basically, when you do an ogive, you're going to get an S-shaped curve. Okay? So you're going to get an S-shaped curve. So just keep that in mind, that we want to have an S-shaped curve. Okay, so other than kind of missing that one point there. I should just undo that, but that's, you can always draw better by hand than you can, plus your eraser works better. Okay. There are 200 data values. Since Q1 is the boundary for the lowest quarter of the data, then Q1 is the 50th. Right? So we're taking 25% of our 200 data values, which is the 50th value. The median will be which value? The 100th, right? 50% of 200. The third quartile will be which value? The 150th value, right? So this is which data value. Now, we want to use the ogive to estimate the following values. So, what is the 50th value? Okay, so we go here to 50, and we go across, and it is about 40. Okay, remember, our data values are of the frequency of the 200 data values, so we're obviously looking along the axis that goes to 200. I want the 100th. 100 is here, and that is about, 47, 48. 40. 47, you could legitimately write 48. Okay, I want Q3, the 150th value, which will be, okay, so 56, 57. Right, in other words, if you're within reason, if you've got a decently shaped curve in that, then I'm allowing some leeway in the answers, right? When I go to mark, it's not, you put 56, it's 57, right? So, because we are drawing by hand, we're eyeballing this. What is the interquartile range?
56 minus 40, which is 16.
So 56 minus 40 or 57 minus 40? So 26 or 27? Oh, sorry. Yeah, 16 or 17.
Oh my God.
16. Yeah, do the math properly.
I almost.
Percentile. Okay, any questions on that little bit? Right? Because all we're doing is filling this in, and then you got work to do, and there's answers closer to the back. So, percentiles. A value is in the nth percentile denoted by p sub n if it is greater than n% of the data. For example, the median is the 50th percentile and is denoted by p sub 50. And the first quartile is the 25th percentile and is denoted by p sub 25. Using the above ogive to estimate each of the following percentiles. So P10.
28. What? 28.
Okay, so the 10th percentile. Okay, so what are you saying? 25? Okay, go with 25. P35. So P35 is going to be about how much?
70? Wait, no, never mind. Why am I thinking?
Okay, wait. What? No, so the P35 is 70 here,
Oh, yeah.
but when we need the number, right? So P10 was 10% of 200 was 20, right? So we go with the 20, we go across to 25. P35, 35 corresponds to 70%, right? So here, P10,
That's right.
P35 is right here, right? Okay, and that corresponds to, say, about 43. P60, where is P60? 120, right? So P60 will be at 120, right? Because that means that 60% is below that. 40% is above that. So at 120, we've got 51. And the 95th percentile, which will be where? 190. So P95. And that's about 78, maybe? Okay? So for percentiles, right, we look for what percent of the data. In this case, we have 200. So what percent, P10, 10% corresponds to 20, a frequency of 20, right? 35% corresponds to 70. Use the above ogive to estimate the percentile ranking of each of the following values. So if you have a value of 10, then what percentile is it? So we're going backwards, exactly.
P5, 2. Oh.
2,
4.
1,
Yeah, 4.
1. Okay, so P1. It's in the first percent. It's a frequency of 2, which is a percentile of 1, right? Because we're talking about 200 elements. Okay, so the frequency is 2. 2 out of 200 is 1. You'll be at P1. 25. Okay, so we go here for 25. Go and across to 20. 20 out of 200 is what percentile? You don't need a calculator, seriously.
Kaylin becoming just as bad as everybody.
Let's go with P10, right? Okay. What's next? 50. Number of customers. 50. Comes out to about 110. Or is it a little bit higher? Yeah, maybe a little, I don't know.
Maybe it's the point that they told us.
Maybe it's the point that they told us, 114. And what percentile would that be? P57. And 70. To 180, right? So P90. Ogive.
Ogive?
Ogive.
Oh God, I'm learning English reading math.
From question 1.
Question 1.
Okay, so these numbers here are the number of customers, right? 10, 25, 50, 70. Use the box plot from question 1 to determine the following percentiles. So, what's P25?
First quartile.
What's the first quartile?
Oh, the first 5 points.
What's P50? Which is the median, right? What's P75? Which is the third quartile. Okay? 8.3. Okay. Any questions? You got well, yeah, there are. You've got 2 pages of them. So away you go. Answers to those are posted at the back. Should be able to do that in the next, we got an hour and a bit. I think that's doable. So do it.